So the last class, what we saw is that very top level view of all the major primary blocks which are used in Terraform. Okay, and some like those are here mentioned on the slide. The Terraform block we saw, which is mainly to the pull the binary. Okay, and restricting the version of the Terraform there, we can do that, and tell Terraform like where to download the plugins provider, those things it will be there in the Terraform block, and provider it will be primarily on the authentication part of the cloud. Okay, and resources block is the main thing where we'll spend more time. Okay, where you create all the resources in either in the AWS, Azure, or whichever cloud you are working on. So for each item, like for example, S3 there will be a resource block for S3. Okay, you want to make a AWS instance, there will be separate resource for that. And the best place to go to identify if you have the corresponding resource or not is the registry.terraform.io. On their website, we can select AWS or whichever cloud we are going, and we will see all the documentation, like whatever resources they have offered. Okay. So then there is a separate category called variable blocks where we pass the inputs. Okay, and one primary is the variable block, and then there is output block to give some output back to the end user to display something on the screen back, and there is a locals value block, local block, where we can fix some variables like you don't want the end user to enter those, and you want to get that fixed in the program itself. So then we use that. And there's a modules block, which is kind of like used for mainly to share the code. So whatever code you have written, you can give it to some other team. You can share it. Okay, so we do it through the modules block. And next comes the data sources block. The data sources block is if you want to get some information into your Terraform code, the item which you have not created through Terraform, but you need those information. So then we use the data sources block. I can give you an example. For example, let's say there is a VPC in AWS, and you want to create a subnet on that VPC. Okay, you have not created the VPC on your own. It is already created by the network team. So in that case, we have to use the data sources block. So we will pull the VPC information through the data sources block, and then with that information, we can create the subnet on that. Okay, so the subnet you will create from your code, and the VPC information you will pull from the data sources block. So anything which is not created by you through Terraform and all, which is already existing, so kind of those information we can bring it to the your code using the data sources block. So these are the primary top level blocks, okay, which we discussed. And apart from that, there are some meta arguments. So the meta arguments are the kind of things which enhance the capability of the existing block. They can be applied on the resource, module, and the data block. Okay, so there are 5 meta arguments. So one is the depends on, so which we saw on the day, like if you want to give a specific flow into your program. So let's say there are 10 resources you want to create. Okay, but so what Terraform will do is it will do in a most efficient manner, and it will do it parallelly. Okay, the fastest way it will try to do. Okay, but maybe your requirement is not like that. You want first resource number 3rd to be created, then resource 2, then resource 5, something like that. You want the flow to be done. So in that case, we can do the depends on. We saw the example last time where we created like 3 S3 buckets in a specific order. Okay, so if you need any specific ordering of resource creation, we can do that. Okay, so many times we will find the use cases. For example, let's say you are creating maybe 3 servers, 3 instances. One is web server, one is app server, and one is DB server. Okay, 3 instances, and you want a specific flow to be done. Let's say first the database server to be created, and loaded, then the app server, and then finally the web server. So in that case, you can use the depends on this meta argument. Okay. And the
Okay.
count and for each are primarily to repeat the block. Okay, so whichever block you want to repeat. So let's say you want to create 10 S3 buckets or 10 VM instances. Okay, so in those cases, instead of repeating the code again and again, those blocks, doing copy paste and all 10 times, you can use the count and for each. It's kind of a loop where it will iterate those number of times how much you want. Okay. And provider is, again, we saw, like if we have different, if we have the same provider but with different configurations. So let's say you want in AWS, you want some resources to be created in East US, some in West US or East US 2 and all. In those cases, we have to use the provider alias and we have to use the provider meta argument. Okay. And the final one is the lifecycle meta argument, where let's say you created a resource. Okay, and your requirement is like this: you created a resource, and the resource is production, and you term it like you want it to be a super critical resource. Okay, nobody should destroy it by a mistake or through any means. Or they shouldn't destroy it. Okay, so you can enforce that the life cycle block. Let's see an example how it is. I think this we have not seen last time. Okay. So resource, where is it? Okay, so let's take this code. Let me create one folder for today. I will upload all this code to the Git so that you can refer it. This all. Okay. This meeting I will put that today's date is 28/05.
Can I ask a quick question?
Yeah.
You mentioned data source, right? What is data source?
Yeah. So data source is if you want to bring any information into your Terraform code. Okay, I will show you an example as well. 1 second. Let's say Terraform. Let's do that. Required providers. We want AWS. Okay. Source equal to HashiCorp/AWS and provider AWS region East one. Okay, so let's do the first AWS underscore S3 underscore bucket. Okay, some bucket we are creating temporarily. Okay, let's go to that folder. 28. The first command we do is Terraform init, so that it will download the plugin and all. Oh, this typo source. So it will see, okay, what provider we're using, AWS. So it will go and download the AWS provider in the same folder.
Okay.
Okay. So once it does the Terraform init, we do the plan. And then we do the, so here it is showing one to add, so it's all good. Terraform apply, and if we don't want the prompt to be done, prompt, it shouldn't prompt us, we can put auto approve, so it won't prompt us, like it is a, we're telling it that default it's yes. Okay, so you can see here one resource is added. So now if I do a destroy, okay, so assume like maybe this is a production, some critical infrastructure, and somebody does the destroy, so it will go ahead and destroy. That's fine. It's the normal way. Okay, but we don't want this to happen. Like we want to protect this from the destroy and all. Okay, so there is a block here called lifecycle. Okay, so when we apply this meta argument, it will come one more nested block inside that. So now here there are some options that ignore changes, prevent. So these are the three main switches we have here, arguments. Okay, so we want that prevent destroy. It is a boolean like true or false. Okay, kind of a switch it can. So prevent destroy we will put as true. That we are saying the Terraform that prevent the destroy. Okay, now this is true. So whatever resource this is in, this resource, it shouldn't be destroyed. Okay, now save it. Let's create
Okay, so
this. Yeah.
so
So
the reason, what is the reason why we want to prevent destroy?
yes, so sometime couple of like production resources will be so highly critical that you don't want to take any chances. Okay, by mistake somebody
Mm-hmm,
shouldn't destroy it manually or through any automated means or some scripts by mistakenly
mm-hmm,
somebody triggering it. So in those
mm-hmm.
super critical resources of production and all, you can put this switch in the code. Okay, in that
Okay.
resource, so nobody can destroy it
So
straight away.
okay, so the switch is called life cycle,
Life
right?
cycle. Yes, yeah.
Okay.
So this is, so these are kind of this is the meta arguments we are seeing. So meta arguments bring some extra capability to the existing block. Okay, so the resource block
Mm-hmm,
normally what it will do, usually it should create the bucket, that's it. Okay, this block, but after
mm-hmm.
adding this, it adds some extra capability to it. Now let's try to destroy it. Okay, our this same resource. Okay, so here it says instance cannot be destroyed. Okay, resource this has a life cycle prevent destroy set. Okay, so that's why it is saying that to avoid this error and continue with plan, either disable. It is saying that you disable this. Okay, like that. So by mistake, if somebody triggers it, okay, without maybe some scripts and all, they're triggering and all,
Mm-hmm.
or maybe some automated script got triggered, somebody triggered it by mistake and all. So this kind of destroy can be avoided. Okay, so there shouldn't be any outage, there won't be any outage for the production instance. So if you want to destroy it, you have to explicitly go and do the prevent destroy equal to false,
Oh,
or either remove it, this block. Okay, so somebody has to manually go and do something to destroy it. So then they will definitely confirm by that time that, okay, is it really a genuine destroy operation, or by mistake something is being done. Okay, so now we
okay.
do a destroy, it will.
So now, what I want to ask is that, so the life cycle would it will prevent destroy for all the Terraform blocks, right? Like stages, I mean,
Mhm.
or just for this particular S3 bucket.
Yeah, just but because it can be applied on resource and resource levels. Okay, so if you have one more resource, maybe something a separate bucket and all, and if you don't have the life cycle, it won't be applied. It will be applied on the specific block,
Only here.
only here.
Okay.
Okay.
So if you want it in all of the blocks, like all of it, how will
Yes.
you do that?
Yeah, you have to apply that individually on that on those blocks.
Okay.
Okay.
Individually.
Yeah,
Okay.
individually on
All
those
right.
blocks. Yeah.
Okay.
So it can be applied on which places we saw, the resource we can apply, on a module we can apply, and a data block we can apply.
Mm.
So these three places we can apply this life cycle or these all five meta arguments, okay, wherever we need. So
So
we
what
can,
is the data block?
oh yeah, yes, good question. So now data block, okay.
Mm-hmm.
So the data block is, let's say, we already have a some resource
Mm-hmm.
in cloud, okay. So
Mm-hmm.
let me log into the cloud. Just a minute, let me get my mobile.
That's fine. Mhm.
So let's create some VPC, demo VPC 10.0.0.0/16. Okay, so now here you can see we have one VPC which the name is demo VPC. Okay, and
Mhm.
it is in the US East one, US East one region. Okay, now
Mhm.
maybe this is already VPC existing and it's in production and a lot of subnets, everything is there. Okay, now your task you got the task to create a subnet in this VPC through Terraform. Okay, so what we will do is if we go and create a VPC, AWS VPC. So what this will do is it is going to create again right from scratch. Okay, the VPC is already existing now in cloud.
Mhm.
So we want to create inside this subnet, like we want to create a subnet inside this VPC. So how
Mhm.
we can do it? We need some information of this VPC, right? To in our program, we need to bring it here so that we can do that. Okay. So for that, we have to use a data block. Okay. So data block. Now, what we want to pull the information is a VPC information, AWS underscore VPC. Okay. You can give any name here, demo, thing like that. And in the data block, it is very minimal information we need. Mainly, primarily is the name of the VPC. Okay. So take the and what is the I think ID. ID is the one we need. Demo VPC. We can check that. AWS underscore VPC. Because many times it's all difficult to remember all the arguments and all for each resource. So we can
Mhm.
refer the documentation and see what all arguments you would need. And mainly we are looking for the data block here. So this is for the resources. We don't need for the resources. We need for the data sources. So now let's see AWS VPC. So yeah, it is, we would need the ID of it. Okay, where dot VPC dot ID. Okay. So ID optional, the ID of the specific VPC. So from the portal, we can get the ID. Let's see if we can get where we can get the info. So logs, tags. Okay, this is the ID. Okay, so this is the VPC ID we would need here. Now let's go back to the code. So this is our ID. So now what will happen now, our this Terraform code is now aware of the VPC VPC information. Okay, so we have to now
Mhm.
create a subnet inside this VPC. Okay, so currently there is no subnet inside this. Okay, we can see the subnets, anything. So we cannot see anything in the demo VPC. Okay, there are no in the VPC section, there is nothing as demo VPC. So let's go ahead and create a subnet. Okay, so resource AWS underscore subnet. So when we create a subnet in AWS, okay, so it would need the information of which VPC we want to create. Okay, so earlier we don't have the information. If we have gone from scratch, we couldn't get that. But now we have the data block, so we can give the information. So here it asks for that VPC ID. Okay, so we can give this now data dot AWS data dot. Now we have all this information now available from that data block. Okay, so we can go get all the information of that resource, the VPC resource. We can get the ARN, CIDR, everything we can get it. So here we need the ID. We can get the ID here. And for our subnet, we need some CIDR block 10.0.1.0/24, and maybe we can give
So
it. Mhm.
okay.
Yeah.
So what makes it a data block? Is it why you creating subnet or what? I'm trying to understand. I don't understand what data block is.
Yes. So data block is bringing some information which you have not created through the Terraform. Okay. So here in this case, the VPC, okay, it is not created through Terraform. Somebody has manually created it. Okay, it is already existing in cloud. Correct.
Okay.
Okay. So we have to the task which we got is to create a subnet in the VPC named demo VPC. Okay. So where is our VPC? So now you got the task that, okay, create a subnet inside the demo VPC. Okay. So the demo VPC is already existing. Correct. So
Mm-hmm.
I cannot create the VPC again. I cannot create that.
Okay.
I cannot create the VPC again. Let's try that. Whatever we will get. If we try to create the VPC again, let me comment it. Okay. AWS underscore VPC. Okay. Demo, and here CIDR block 10.0.0.0/16. What else we need? Yeah, and tags demo VPC. Okay, because we got the task that create a subnet in a demo VPC, in the VPC named demo VPC. So that is our task which we got. Create a subnet in a VPC named demo VPC.
Some of the
Demo
people.
VPC. Okay. So now we got that. Okay, the VPC name is demo VPC. Now we are creating it. Okay. So Terraform can create new things. It can create a new resource. So now what we will do, we'll do the Terraform plan. So here it says, okay, one to add. So let's go and apply that. Okay, one second. Let's say it created with a different ID, I think. Okay, so here you see now it created a new VPC. Okay, it has not
Mm-hmm.
like we want to be created in the existing demo VPC, whatever is there. It created a new VPC with a different ID. Okay, so it doesn't meet
Okay.
our purpose. Like the requirement is to already create inside that existing VPC. Okay, so whatever we will do now, it will create that in the new in this new one. Okay, which we don't want. We want it to be created in this one, which is already existing one. Okay, so
Okay. So
yeah,
so what I can
mhm,
okay.
yeah,
So what I can understand by a data block
mm,
is creating resources in an existing resources, right?
correct, yeah. Yeah, so
Okay.
to add or to get the information from any existing resources where you don't want to create it from scratch. Okay,
Mm-hmm.
so in those scenarios, your choice of weapon will be this data block. Okay, so there are two things. There is a data block in Terraform and there is an import in Terraform. So here, what you can do in data block is you can get the information. That's it. You cannot go and change it. So this existing whatever VPC is highlighted here, I cannot go ahead and delete it. Okay, I cannot destroy it. So the data sources, the data block is to merely get the information. That's it. Okay,
Okay.
you cannot destroy it, the whole thing, because Terraform has not created it, so it cannot
It was
destroy it.
yeah.
Okay,
Okay.
okay.
Mm-hmm.
So if your requirement is to go a level further, that no, I want to completely manage it. Okay, from Terraform, I want to go ahead and destroy it as well through Terraform. Then the next level is you can do a import of that resource, Terraform import. We will see that in the next subsequent chapters when we are doing the state file. Okay, how to bring the resources into Terraform control completely. Okay, to manage through Terraform. So let's say there is a company who already is in cloud and like they currently they are already in cloud, all the production servers are running in cloud and all, but now they want to manage it through a CI/CD pipeline and through IAC tools like Terraform. Okay, through so in those cases they have to import their state, their production infrastructure in cloud to the Terraform. Okay, using the Terraform import, so that they will start managing. They can do the destroy, they can do the change, whatever they want. Okay. Otherwise, Terraform will create from scratch. Like Terraform is a tool where you can create it from scratch. Okay. So these two options are there: data block and a Terraform import. Okay. So let's get rid of this one. So we destroyed that resource. Let's refresh it. Okay. So our second duplicate demo VPC is gone now. Okay. So
Mm-hmm.
we are left with only one.
VPC demo,
Yeah, only VPC demo. Okay.
which was created without Terraform, right?
Yeah, yes. We console
Okay.
through console we created it.
Okay. So I know I asked what data source is. Did you explain that?
Which one?
Data source. What is data source?
No, it is the same thing actually. The same data source. The block name is data block. Okay.
Okay, okay. So data source is the same thing as
Yeah,
data
yeah,
block.
as data block. Through.
All right. Okay. So what's the difference? Just the block?
Yeah. So data sources like is the term to get some information into Terraform, but data is the actual block name. The block name is data block. Okay.
Okay.
So where is it? Yeah. So the data sources block, we call it a data sources block, but actual the block name is local. Sorry, in the data block here. There is no name as data sources and all. Is the term which is used here. Okay.
Okay.
So,
You said I didn't get that. There's no such name as data source, or what did you
yes,
say?
yeah. So data source, because this is giving an example of a VPC, but there could be
Mm-hmm.
things there where you want something from a database. Okay, from a SQL database, you want to get some information, or maybe you want to read a file and want to get some information. Okay, so that's why it is
Mm-hmm.
very generic term called data sources, because there are various sources of data is there. Okay, so for everything, but the block name will be data block.
Okay.
So maybe you want to read a file, and from that, whatever value is there in the file that you want. So in that case, yeah, we can use that. Okay. So the block name will be always data.
Okay.
We'll see when we
Gotcha.
go the next chapters, when we go about read the CSV files and all that, we'll see, we'll further revisit this data block. Okay.
Okay.
So now we are creating the subnet block. Here we have created the resource AWS subnet. The subnet will reside here in this VPC. So VPC
Mm-hmm.
ID is taken from here, this block. Okay. CIDR block is within the ranges of the, is a subset of the VPC range. Okay. And we have given a tags demo subnet. Let's do
Okay,
the.
please. I'm sorry. I'm going to take you back to data source. It's really, I just want to make sure that I'm getting it right. So, data source is an existing information or existing resources of a company or of enterprise or whatsoever. And then, if you have to get like it consists of information, right?
Mhm.
And then you can okay. I mean, that's all.
Yeah, correct.
Did I put it
Yes.
right?
Yeah. So, like to get any input. Okay. So to get some input, we have already a variable block which we saw, right? The user can enter something. That is kind of
Mm-hmm,
one or two inputs. That's fine. But think of a scenario where you want to read hundreds of lines from a file. Okay. Or maybe from a database you want to read thousands of lines. Okay.
mm-hmm,
And maybe you want to read some objects from existing S3 bucket. There are hundreds
mm-hmm,
files there in that S3, and you want to read the names and all that. Okay, so that won't
mm-hmm.
be feasible by somebody entering those names or capturing it in some like that. So in those scenario, we have to use the data block where you want to pull some information from some other sources which Terraform is not managing. Okay, so for example,
Oh,
this VPC,
gotcha.
Terraform is not
Mm-hmm,
managing. Terraform cannot destroy that VPC and all, but it doesn't
mm-hmm,
manage. But it merely needs the information that it needs only the ID of that VPC. So
mm-hmm.
in those cases, where you are pulling some information from outside of Terraform, yeah, you have to use the data block. Okay.
Okay.
Yeah. And now on that information, we can build the things further. So what you will do with that information? So once we got that information from this data block, like we are writing data dot this block dot demo. Now, now it has exposed us so many information from for that VPC ID. We can get the ARN, CIDR block, DSV, everything, whatever information we want. As a
Mm-hmm,
VPC, we should get, we get all that information. Now here we
mm-hmm.
need the ID. Let's, so let's do that. And now do a Terraform apply. So here it is saying one to add 0 to change. So it is added one subnet. So let's see if our subnet is got created in the same VPC or not. We'll go to subnets. Okay. And in this column, where is it our, what is the subnet name we have given? Oh yeah, this is our subnet name, demo subnet. Yeah, demo subnet. Okay. And the VPC belongs to this C00 demo VPC. Okay. So in the same VPC, now we created our subnet. Okay. So this 10.0.10.0.10/24. So now this completes our task. How it is, what task we got is to create a subnet in a VPC named demo VPC. Okay, so it meets our parameters. Okay. So these are some of the use case where we would need a data block. Okay. Let's see that. So these are the high level, top level blocks Okay, and these are the meta arguments depends on. So this is the main thing, like where all our day-to-day tasks will revolve within these blocks or the meta arguments and all. Got it. So now coming to the basic Terraform command. So Terraform
Mm-hmm.
has got a lot of commands. Okay, but on our day-to-day working, like here, the commands are a bit separated. We can do a Terraform dash help to get the commands. Okay, Terraform dash help. So they have split the command across two things. One is the main commands, which we will
Mm-hmm.
use day in, day out. Okay, Terraform init, validate,
Validate.
plan, apply, and destroy. Okay. So some of the commands like are not explicit, like for example, Terraform validate. It just checks our code is all syntactically correct or not. So Terraform validate right here. It will say kind of a okay or not how. Yeah. So it is kind of a success. The configuration is valid. You can use this output in some maybe shell script or something like that to get a or you want to create test cases. Okay, that all the test cases find like syntax error checked and all through that. So it gives only a one line success. If success is there in the output, then all code is all fine. Okay.
I'm sorry, I don't understand the Terraform validate.
So Terraform validate will do the syntax check only. So for example, here, okay, here I have written something VPCA or something like that. Okay. Okay. So here it will check the same thing, like any errors are there or not in the
Mhm.
syntax of your program. Anything.
Okay.
Okay. So any mistake is there or not, like that. Okay. So
So is it
mhm.
okay? Is it always advisable to use Terraform validate after writing your Terraform script?
Yeah, yes, because the thing is that some of the things are inherently happening. Okay, so even if there is a 1 second, we will do one thing. We'll do the same thing. A here and IDs here. Okay,
Yeah.
and we don't do that. Let's say Terraform validate, and we directly do Terraform apply. Okay,
Okay.
so what happens in that same apply also? It is going and doing the validate anyways. Okay, it will even do the plan
Okay.
itself and all. So
Oh,
if you
gotcha.
want, you can do it, but in best like kind of ideal scenario in a pipeline when you are doing it, it is advisable to do that validate. Okay, so it could be your one of the test case scenario that if the output is having the string success, then your test passed. Okay, your syntax check is passed, kind of thing. Okay.
You mean only when doing the pipeline or what?
Yeah, on maintaining the pipeline and all. Okay, and where you don't want to apply, you just want to see the code syntax. So on those scenarios you can do the validate, where you don't want to do a apply or anything. You don't want to get the resources created, just you want to see the syntax, is it correct or not. So that time you can use the validate. Okay.
Oh, okay.
Okay, but not mandatory. So it's okay.
Okay.
So even if Terraform plan is there, it will also go and do the validate itself. Okay, so either you do the Terraform plan or apply and all, it it
It's the
will
same
it,
thing.
it will yeah, it will go and same thing, it will do the same thing. Okay. So
So in that case, they shouldn't have invented validate since plan does the same work as validate.
yeah, but the other the if the syntax is all correct. Okay, if the syntax is all correct,
Mm-hmm.
so what the other things will do is Terraform plan. So it will generate a very long output and all, and okay, so it anyway does the syntax checks and all, and
Mm-hmm.
it is not predictable information. Okay, so but in validate, what is happening, Terraform validate, if your syntax is all good, it is returning only one line of string back.
Success.
Okay, success, that's it. So as it, if you want to create a test case, like in your pipeline, if you are having a multi-stage pipeline and one of the stages to the first stage is to maybe check the code, okay, syntax code. Okay, so
Okay.
in that case, it is a very easy way. So output of the Terraform validate, if success word is there, then it is test case is passed. Okay, otherwise halt it there only. Okay, so in very specific use case, you can do that Terraform validate.
Okay. Okay. Gotcha.
Yeah. So that is, so what we are looking the Terraform help. So yeah, Terraform dash help command. So here it has told the main commands are this Terraform init we are aware now. Okay, Terraform validate we saw. Plan also we know, and apply we already did, and destroy also we have seen. Okay, so these are the main commands which it, as per Terraform themselves, like these we are going to work day in day out. Okay, there are other commands which on need basis we will use those. Okay, there is one quick command I want to show you. The other commands we will refer when we are going to the state files, or when the actual uh, topic is there, we will revisit these specific commands. Okay, for example, the import command is there, and state command, show command, okay, taint and all. At the specific time, we will go through that. But this FMT command I want to show you now. Okay, so let's say your code is like this. Okay, your code is like this, something. Okay, okay, not looking very neat way, right? Means not looking in a proper way. Okay, so you see, like somebody like whoever is written it, it's not in a proper readable format. Okay, the arguments are not spaced properly and all. So what we can do, we can use the Terraform fmt. So what this command will do, it will go and check in the this folder, whatever Terraform that the TF files are there. It will go and do the formatting kind of. It will do the canonical format. Okay, it will do the spacing and everything correct. So let's run it. So you see here, the spacing and all is got properly. Okay, and it's now more human readable. Okay, so if you by mistake here given like
Cool.
that,
I like this.
yeah, yeah.
Yeah.
So you write in whichever way, and at last you do the Terraform FMT. It will make
Hmm.
it nicely. Yeah. So you don't have to worry for that spacing and all. Okay.
I
So
think I'm going to be using this a lot.
yeah. So it's a quite helpful command. So even if you are not using any IDE and all, you are doing it
Hmm.
in Notepad maybe.
Hmm.
So in
Hmm.
those cases, you can put that, yeah, the Terraform FMT command at the end.
FMT,
Okay. So it will beautify. It will
which
put in
means
a proper,
format.
yeah, proper way. It
Okay.
will do that. So that is one command which is fine. Other commands which are not very frequent, we will see in when we are going through the appropriate topic. Okay.
Yeah. I
Uh,
think the FMT is quite
yeah, quite
fancy and
quite
interesting.
quite
Yeah.
helpful command. Yeah. So I think there is a big piece of code, hundreds of lines of code, and again somebody manually doing that is painful. So you run one
Hmm.
command, it will do everything. Okay, in that entire folder, what how many TF files are there, it will take care of all the files. Okay, so that is for that Terraform FMT. Yeah, so these are the commands I also highlighted initially at this stage, that at least we should be aware: init, plan, apply, destroy, validate, and FMT. Okay, the next of the commands we'll see when we are going to the appropriate topics, okay, which will be feel more relevant during that time. Now coming to the next section, okay, this is our first intro section kind is over, which is a very high level view of the Terraform. Okay, where is the topic? Sorry. Yeah, so we are done with the first topic, okay, which is kind of an
Yeah, but I
introduction.
have a question. I have
Yeah,
a question about the spacing.
yeah.
So if you have like a rough work, maybe a lot of spacing, just like before we use the FMT, the example you gave, um, can we can we apply like Terraform apply and it won't bring out any error, or will it come out with
No,
errors?
yeah, no, it won't come out. Those are kind of it doesn't take into account that spacing or like that. Okay, so whatever
Okay,
way it is there, it won't care. Okay, it will run fine. There is no syntax error or anything like that. So here
so
it's
it
all,
will
yeah,
create.
yeah,
Okay.
it's all a bit of only the looks kind of is not looking a more readable format, but
Mm-hmm.
for
Mm-hmm.
Terraform point of view, it's all fine. So it doesn't take care. It won't matter for him. Okay, so now we do Terraform validate.
Apply.
Yeah, validate
Okay.
also will
Well,
show the code syntactically. Okay, it's all fine. And Terraform
okay.
apply also shouldn't be a problem because it's all fine. Like this is not a syntax error or anything. It's
Mm-hmm.
just the format, the look and feel you can see here is like that. Okay, so our already subnet is there, so that's why it is saying that no change needed. Okay, for that. So this is all fine. You can just run Terraform FMT. Immediately it will bring all the code to bring to
Yeah.
original, more
Okay.
human readable format. Okay.
Yeah.
Yeah.
And just to make your work look neater,
Yeah.
kind of.
Yeah.
Mm-hmm. It's fine. Okay. Gotcha.
So we are done with the first topic, which is kind of was the intro of Terraform, what it is, IAC, gone through the basic tools, what we would need. Okay. And we saw high
Mm-hmm.
level basic syntax, block level info, introduction to the
Mm-hmm.
blocks and meta
Mm-hmm.
arguments. Okay.
Mm-hmm.
And we saw few of the important primary commands. Okay. So
Mm-hmm.
now we will see more into in depth of the each primary block. Okay. So
Mm-hmm.
first, in the second section, we are going to visit the Terraform block and the provider block. Okay, in more
Okay.
detail. So let's go through that.
Okay.
So now let's see what will. So in the Terraform block, we already saw that the required providers, there is a nested block is there, which says what all provider we are going to use. Okay, we have to highlight here. So let's say if you want to create something in Azure, we have to use the proper Azure one, or the GCP ones, we have to use the Google one. Okay. And here in our use case, we are using we want to create some resources in AWS. So we have to declare it here that, okay, AWS. Okay. So like, for example, even um, uh, if you have some other cloud, okay, in the same program. So let's say if we have something in the Azure as well. Okay. So, okay. So we can do that here. So now let's see in our Terraform block, what all things are there. This is our base folder. So when we do a Terraform init, it creates a folder .terraform, and inside that the provider will be downloaded, the plugin. Okay. Now we have got only one plugin or provider. Both are synonymous. Okay, but they mean the same thing, plugin or the provider. So we have the AWS at this point. So we added one more. So when we added one more, anything you change in this block, you need to do always a Terraform init. Okay, because it has to initialize. It cannot take it in runtime. Okay, like when you do apply and all, it will fail. That it will say that you do the init. Okay, so we do the Terraform init. Okay, so here it is showing that, okay, now we had added one more. So it is downloading the Azure RM. Okay, so here if I refresh, one more folder would have come now. Yeah. So one more folder appear here, Azure RM, and it downloaded the plugin also for that. Okay, so this block is the required providers block is for whatever capabilities you want your program to be. Okay, let's say you want to generate a random number. Okay, so for that also you need some capability. Okay, some software would needed. So that also will come from the required providers only. Okay, so there is a required provider called random. Okay,
What is Azure RM?
Azure RM is for Azure. If you want to create something on the Azure cloud, okay, then you have to use the Azure Resource Manager. So like how AWS uh, is called, the provider is called AWS. In Azure, the provider is called Azure RM. Okay, Azure
Okay.
Resource Manager. Okay.
Okay.
So similarly, any new capabilities you want. Okay, so for example, now this line, these three lines has given us the capability to create something on the Azure cloud. Okay. Now let's say we want some capability to generate a random numbers, okay, or random string or random characters or a random password kind of those things. So there is a plugin, there is a plugin or provider called random. Okay, source equal to HashiCorp/random. Okay. So now we will do again whatever we are doing it here. We are adding here. We have to always do a init. Okay, so it will go and finding latest version of random. And now if we, yeah, it has created the folder for that, the plugin. It has downloaded the provider for that. Okay, so this this primarily this block of required providers is, we will update it as and when we need some new capability in our code, okay, to create the resources or anything we want. Okay, and again all those things will be mentioned on the documentation of the registry.terraform.io, the main page itself. Okay, so in the main page, browse providers, we go. So let's say because in DevOps you can get the things to create any, like it depends on the requirement, it can be any, I don't know. So for example, Google Cloud, you want to create something, so click on the Google Cloud, and when we go for use provider, it will it will tell us that okay, we our required provider blocks will should look like this. Okay, these are the extra three lines, which these two lines are the extra lines. Okay, version we will see at this point. Okay. So this is the place where we can get the information about the providers. Okay. Now this is the required provider block, and again in this required providers, okay, AWS, you will see here AWS, okay, provider. So this you see are very dynamic. Okay, 21 hours ago we got the version 4.16. 8 days ago this one, like that, 9 days ago this, 15 days ago the version was this. Okay, this is the version for the provider or the plugin. Okay, so it is very dynamic, it's changing. So how you will, we will ensure that whatever code we have written today, that will hold good after 6 months as well. Okay, because the things are moving, all the things are moving. Actually, the AWS provider is getting updated from HashiCorp. Even the AWS vendor is changing their backend cloud things. Okay, and Terraform.exe file versions are also changing. So in this changing world, how to fix, how to pin, like pin it, that our code should run in next 6 months, 1 year also. So what? So for that we can give here the version also. We can hard code the version here if you want. Okay. So today the version is 4.16.0. So we can do here 4.16.0. Okay, we can pinpoint the version here. So what this will do is, it will ensure that whoever is using this program, when it is downloading from HashiCorp, the AWS provider, no matter whatever the version is at that time, it will go and download this specific version only, 4.16 only. Okay, maybe let's say we want to run it on 4.14, 4.14.0. So what we will do here, we will fix it here, that 4.14.0. We want this version of the plugin to be downloaded. Okay, because currently here, if you see in the folders inside HashiCorp, inside AWS, you can see the version 4.16 is there. But we are right, we want the 4.14. Maybe our program will run only on that. So that time we will pin it. Okay, we'll pin our code to run on this specific version only. Got it, right?
Yes.
Okay. And in the same way, yeah, we can pin the version of the Terraform also. Okay, the terraform.exe, whatever we downloaded. So terraform hyphen v. Okay, so our version, my version, whatever I'm using is Terraform v 1.2.0. So I can pin the version here as well. Okay, the required version equal to 1.2.1. Okay, so now whatever I will code here, now this our entire program is pinned kind of. Okay, if these two conditions are satisfied, if the person whoever is running this code is having a Terraform version of 1.2.1 and the provider version of 4.14.0, then go ahead and run this program fine. Okay, because we are testing in this in this in this version, right? Who knows, after like 6 months what will be the Terraform version? Terraform version might be 1.8.1. Okay, and this AWS version might be 6 dot something, who knows? Okay, so and it is not guaranteed that whatever code we have written here may work on that latest version or not. So through this way we can fix it. Our program should only go ahead and run on this. So now when we do a Terraform init, we have to do Terraform init again, because any changes inside the Terraform block, it would need a reinit, because now we have done the version, we have downgraded it 4.14.
Mm-hmm.
We had earlier 4.16 downloaded. So we will do the Terraform init.
That is upgrading the AWS version, right?
Yes, yeah, the AWS version. Okay,
Okay.
so 1.2.0. Yeah, so like it gave a complaint here. Okay, because by mistake I wrote it like that 1.2.1. So then it is saying that okay, is it the configuration does not support this, because I'm running in 1.2.0. So this kind of error the end user will get if they are using some other version. Okay, so
Okay.
we can fix it now. Our whatever test we are doing at this point. Okay, because you'll
Sorry,
spend.
give me a sec.
Yeah.
I'm sorry. So the AWS version has to go with the Terraform version. Is it? Is it that?
Uh, no, those both are different. Okay, so
Mm-hmm.
but what is the thing is that the Terraform version, okay,
Mm-hmm.
the Terraform version will talk to the provider, right? Will talk to the plugin or the provider.
Mm-hmm.
So it is advisable to fix both the versions. Okay, because the changes
Mm-hmm.
on the AWS plugin can
Mm-hmm.
impact. Okay, so what HashiCorp says that it is not guaranteed all the time that required version will impact or not. Okay, so but it is advisable to fix in your program. You can fix both the things. Okay, because you are spending a lot of time and effort to write your code. Okay, so at time only you can fix it with that those required version and the provider version. Okay, because both are dynamic actually. Both can change right down the line. Okay. So, but we cannot guarantee. So
Okay.
even if you have not given the Terraform version, it can or it may or may not run fine like that. Okay, there is no guarantee. Okay, so
Okay. So yeah, but my question is that
mhm,
because I know it was 1.21 before, right?
yeah,
So why can't we leave it at 1.21? Why do we have to change it to 1.20? After like upgrading the AWS version to the 4.14.0.
yeah. So this is completely separate. Okay, so this is for the Terraform version. Okay, this is
Yeah,
only for the plugin version. Okay, so
yeah.
if we are not pinning the Terraform version, so that's fine.
Mm-hmm.
So this we are talking only of the AWS plugin. So here it says
Okay.
could not retrieve the list of, so it is saying that use this command terraform init upgrade. So I'll go and do the terraform init upgrade. So it will go and download the specific AWS version here. So currently we already had a updated one, so it gave that error
Mm-hmm.
to us that, okay, are you sure that you want to do that? So it is now downloading the one whichever we want, 4.114 4.14.0. Let me refresh. It's still downloading. Yeah, so you see here now it downloaded the 4.14 version. Okay, so our program is now tested. Like whatever you're writing, you will spend a lot of
Mm-hmm.
time, couple of days and all, to test everything. Okay, you will create 100 lines of code and all. So now everything you are fixing it, like you are testing it on this version, right? Down the line, like because
Mm-hmm.
the we saw here the version of the plugin is very frequent, right? They're changing is very frequently. 21 hours ago here, 8 days ago the version changed, 9 days ago, 15 days ago. Okay, so they cannot guarantee, or nobody can guarantee, that whatever code we have written may work on a newer version or not. Okay, but what Terraform in general, they say that, okay, the minor version, so this is the minor version. Okay, this is the medium, sorry, this is the fix version. Okay, kind of patch fix kind of thing. This is the minor version, and this is the major version. Okay, so 4 is the major, this is the minor, and this is the patch fix kind of thing. Okay, so what in general Terraform says that, okay, the last one, it's fine. So whatever code you have written, okay, will run fine uh, in the minor version, even if it is changed. Okay.
All right.
Yeah. So this is giving the now what we learned is that on the required provider blocks, we
Mm-hmm.
how to put the version constraint. Okay, or
Mm-hmm.
how to put the uh, fixing the version. Okay, so now uh, this is the patch version, like patch kind of number. This is the minor number and this is the major number. Okay, so I don't have to fix it on each version. So what, let's say I can use wildcards and some kind of uh, greater than, equal to, those kind of conditions also I can use. Okay, so I can use like this, less than 4.19.0. Okay, so I can use maybe less than, equal to. So what will happen, this code, if you are sharing with somebody other person this code, so what it will do, it will check whatever AWS version, if they already are having the AWS provider within these ranges. If the constraint is satisfied, then it's fine. It will no, it won't download the provider again. Okay, so let's run this again. Terraform plan. Okay, so at this point, our uh, our AWS plugin version we saw is within that parameters, right? AWS provider version we are using 4.14, 4.16, so it's all matching. It's all condition is satisfied. Okay, so let's say we put a condition which may not satisfy. We'll put a condition that if the version is greater than 4.19.0, then run this. Okay, so let's do the plan again. Okay, so here you see it gave the error that inconsistent dependency
And there's a log file.
log file.
Yeah.
So it can, the following selections recorded in the log file are inconsistent with the current configuration. So our log file, so there is one more file called, when we do the Terraform, when we did the first time in it and all, so it recorded here in this file that, okay, the person, whoever is writing this code, is going to test everything in this version only. Okay, so it is kind of a lock that it is recorded that 4.14 it is all tested. Got it. So now when we change the condition, so here it is giving us the error that, okay, uh, whatever code was written was for 4.14, Okay, so it doesn't match this condition. So either you update your code to match this. Either you do a init again and get the latest one which satisfies this condition, or you check this condition. It is saying that. Okay, so it is alerting in that way. So what? Uh, so this kind of conditions we can use less than equal to something. So you feel that okay, 4.19, our our code is not a major kind of it doesn't take a lot of features from that provider. So you strongly feel that 4 dot what is the current version, 4.14. Okay, so maybe 4 dot it will run fine on 4.14, 15, 16, something like that. Okay, but you feel that okay, it may not work on 5.0. Okay, so in that case you can put that maybe 4.20.0. Okay, it will run fine. Less than that, you strongly feel that there shouldn't be any major change by that. But after, or or we can say less than 5.0.0, we feel that okay, 4 dot whatever is there, it's all fine. These are all minor version. When it goes to the major version change like 5.0 something, then we feel that okay, it can break it. Okay, so we can put the conditions like this. Okay, less than equal to, we can even give it a range as well, like greater than equal to 4.14.0 and less than equal to 5.0.0. Okay, so it should run fine in that range. Okay, comma greater than equal to 5.0.0. So we can give it a range also. Okay, like it can run fine in 4.14.0 to less than equal to this. Okay, why we do that, this kind of thing? When when you're programming for the production things, you may test your code across multiple versions. Okay, so you may feel to test it on a range of versions, maybe the 5 minor versions and all. So in that case, whatever test cases passed, you can put it in that range. Okay, so
Okay.
this also the conditions should satisfy, because we are on the 4.14.0, right? So we have given greater than equal to. Okay, so it matches this condition, so it's all fine. Okay, and we can also give not equal to. We can use not equal to, not equal to. So this code will run uh, won't run on this version. Okay, any other version it is all fine. So is the condition getting satisfied? So our version is currently 4.14, right? So what we are saying here, this code should not run on 5.0.0. It shouldn't. So our condition is ideally getting satisfied. Okay, because we are not on this version. Okay.
So you want it to run on, so it won't run on this version, but lesser than this version, right?
Yeah, anything, any other version. 5.0.1 it will run, 4.9.9 it will run, but not only it won't run on 5.0.0. Okay,
That means
something,
you
yeah.
want
So you found some bug maybe on a specific version, so that you can
Mhm.
highlight in this way. So this is also one of the wildcard which we can use. And the best one, the one which HashiCorp gives the recommend is to use this tilde character. Okay, tilde character and this sign like this. Okay, and what it does is, I will tell you, 4.14.0. Okay, so what it means is the the rightmost character is ignored in this. Okay, so here what will happen is um, it will run fine on 4.14.0,
Mhm.
4.14.1,
Mhm.
4.14.1, 4.14.2.3.4.5. It will run fine. Okay, on so leftmost, sorry, the rightmost character it will ignore. So whatever is this, whatever version it goes to, it will run fine. Your program will continue to run fine. But as and
Wait.
when, yeah,
Okay. Go ahead.
okay, as and when it goes to 4.15, so let's say the latest is now 4.15, so your program will stop working on that. Okay, so
Okay.
and you want further, like you want, you are not worried about the patch fix number or the minor number also. So then you can do like this 4.14 you can give, sorry, 4.14. So what it means is our program will run fine on 4.14.0.1, anything 4.15 will run fine, anything 4.15.1.2. It will run fine on 4.16, 4.17, okay, 4.19, whatever version comes, but it won't run fine on 5.0. Okay, so rightmost character is ignored. Okay, so this character is ignored in this way. Okay,
Okay.
so this one, our condition. Okay, so our condition satisfied in this, so it is going. So let's say we put it at 3 here. Okay, so do you feel it will, our program will run fine or not now?
Well, it will run fine.
Okay, how? So
Oh,
rightmost character is getting ignored now, but our code in the lock.html says 4.14. Okay, so let's see.
so it will run fine because of the three.
Yeah.
It's that is lesser than 4 dot it's lesser than 4.14, right? So
Hmm.
but it will only run on anything from 4.1, 2, 3, like four, right?
Yes, yeah, correct. You're right.
Okay.
So it will, our program will only run fine from 4 dot anything, 4 dot anything, it will run fine. Okay, but
Mm,
anything 3 dot or 5 dot and all, it won't run because we are only
one.
ignoring the rightmost character. That's it. Okay.
Okay.
So here we, so in this way, if this is the example 3.14, our program won't run because our dependency file says 4.14. Okay.
Mm-hmm.
So the rightmost is not matching. Sorry, the leftmost is not matching here.
Nothing there.
Okay, so we can put our photo button. So in this way, you are what you are doing. This is the advisable way for the from the Terraform side as well, where there's where they say that uh, you can
How about the
ignore the,
zero? Yeah.
yeah, you can ignore the rightmost character. Okay, so you feel fine that okay, it is covered for next 6 or 8 months like that. Okay,
Mhm.
4.14.0.123, whichever is coming. Okay, if you are, if you're very sure that okay, your resources is not using a lot of complicated things and all,
Mhm.
okay, so then you can ignore the rightmost also, you can put like that. Okay, so you are covered in 4.14, 4.15, anything and all, but the major version, you are covered. Okay, so
Okay.
so this logic we can use here into the home. This is clear. Okay, so the same thing now, this was all for the provider version, okay, which we are downloading from the HashiCorp site. Now what about the Terraform version also? Okay, because there could be, in the Terraform we saw there are two things, right? The Terraform core and the Terraform plugin or the provider. So the
Mhm.
Terraform code also we can pin it, okay, using the required version. So I am using the Terraform as Terraform-v is 1.2.0. Okay, maybe maybe you are going to share this code to some of the user who is using very old version of Terraform, like point
Mhm.
12, 0.12 and all, which you
Mhm.
feel that, or you are sure that okay, it may not work on that old versions. Okay, so in
Mhm.
those case, to future proof your program or to cover a lot of users, like you can give a constraint here as well, so that your program should run fine. Okay, so here we are testing on 1.2.0. We are pretty sure that it will work fine. After it should work fine from 1.0.0 to 2.0.0, something like that. Okay, so we can use the exact similar way here as well, but instead of 4 we will use 1.0.0. Okay, so our code, sorry, 1.0 I've written here. So now our code should run fine on 1.0 dot anything, 1.1 dot anything, 1.2 dot anything, okay, 1.3,
No
1.4.
one knows.
Yeah, but
It will run on.
yeah, but it won't run on 2.0.
Mhm.
Okay, when it reaches 2, it won't run. Okay, because we foresee that okay, there could be some major changes in the new version of Terraform, the major version. Okay, where it might need a revisit to manually check it and all to update. Okay, so
So if you wanted to Okay, so what if you have this existing version already and you now want to change the version to um 2 points, to any other version bigger than 1.0? So
Ah,
that means do you have to remove it or what?
yes. So if the user is using a very lesser version of the Terraform,
Mhm,
okay,
mhm,
like we have seen in organizations they're still using 0.14, 0.12 and all.
mhm,
Okay, so in those cases they have to update their Terraform version, the Terraform binary,
mhm,
to match this constraint.
mhm.
Okay, so because that will be relatively easy to do the change from their side. Otherwise, you need to change your code to satisfy their version, whatever they're using. Okay, so that is more challenging. Okay,
Complicated.
yeah, that is more complicated. But to change the version, it is easy because that version is hard coded in the is given on the pipeline. On the pipeline,
Mhm.
there will be a task to download and install Terraform specific version. So there will be a change on that place. That okay,
So
download
I
the.
have a question. I
Mhm.
mean, what is the current version of Terraform right now?
Right now it is 1.2 dot something. I'm not sure the exact latest version. Let's see.
Okay. So
Terraform.
if my company is using
Mhm.
uh, 1.0,
1.2.1. Yeah, current version is yeah.
okay.
Mhm.
If my company is using 1.0
Yeah.
and they want to upgrade to 1.2.1, how will I do it?
1.0 and 1.2.1 they want to do.
Mhm,
Okay,
mhm,
so in those cases you have to first analyze, okay, what will be the impact to the code. Okay,
mm,
so a lot of code, most of the like 18 to 90% of the code will run fine. Okay, wherever,
mhm,
because you already are running in the 1.0, right, the major version. So
mhm.
if you are in the same major version, there is relatively less damaging changes.
Okay.
Okay, if you are already there in 1 dot something and you are going to maybe 1.1 to 1.5 something, there should be relatively, it should be fine. Okay, it is only change on the download newer version. Okay, but
Mhm,
if you are in the, for example, if the organization is in 0.12, okay, 0.12.1 something, and they want to go to 1 dot something, okay, where the
mhm,
major number is also changing, the first digit itself is changing. So in those
mhm,
cases, there will be more extensive change checks needed to check
mhm,
the providers. Okay, because a lot of design level
mhm,
changes happened on the point 12 version, point 13 version,
mhm,
0.12, 0.13. Okay, a lot of new
mhm,
changes came which are incompatible with the newer version. Okay,
mhm.
so only on those areas you need to check more. But if your major version is same, like 1.0 to something 1.2 and all, it should be relatively easy. Okay,
Okay.
so which is only changing this line. Okay, okay, here if you don't have this line, then it will be on the pipeline. Okay, download whichever version, because in the pipeline we fixed that download that specific version of it. So there we need to change it. Okay, okay, so this is the Terraform version, and this is the AWS, sorry, this is the plugin or provider version. So as part of
Yeah.
best practices, Terraform says that to pin this both the things. Okay, what will happen if you skip these two things? Okay, let's say in your code this is not there at all. Okay, these
Mhm,
things are not there at all. Okay, so when you are sharing this code now to somebody else, okay, maybe he is using after 6 or 8 months, and he is using on a different Terraform version, one maybe 0.12 or some old version, or AWS plugin some different version. Okay, so it is not guaranteed that these all exact arguments VPC ID is will work on that version or not. Okay, because these all things are may change from version to version. They will give new capabilities, new features and all. Okay, so that is not guaranteed that your code will work fine or not in that, on whatever the user might be
mhm,
using. So that's why they recommend that to, as a best practice, you pin your code in that so that it keeps on working. Okay, till, yeah, so whoever is using whatever version they are using, it will go and download this specific version only. and it will,
Mm-hmm.
your program will run on that. Okay. So this is the one thing in that, and let me see what there. Okay. And in the same way, like when we are doing the init and all, so we saw there is a file got created, right?
Mm-hmm. Yeah.
Terraform.log.hcl. So this file again, here it is written clearly that file is maintained automatically by Terraform init when we do that. So they recommend not to edit this file, this Terraform managed file. Okay.
Mm-hmm.
And here it has wrote the constraint, whatever constraint we have put in our code. Okay. We have put the constraint as 4.14.0. Okay. So it has recorded that. And
And you
our,
can also see the version there.
yeah. Oh, yeah.
Okay.
Yes. Yeah. The version as well. So no, the Terraform version won't come here. It is only mainly for uh,
AWS.
the AWS, the plugin version. Okay.
Mm-hmm.
So uh, this will run fine. So when we share this file, we have to give this as well. This file also to be included in the while sharing that. Okay,
Mm-hmm.
terraform.log.hcl. Okay. And the next is given. Okay. So it's here we are saying this is the file terraform log HCL. Okay.
Mm-hmm.
And version constraint within the configuration itself determine which version of dependencies are compatible, and it remembers, the Terraform remembers the decision, and it puts that in the log file, in the dependency log file, so that the same decisions can be taken in future. Okay. So yeah, so in this way, now we have the 4.14 version downloaded, right, in our folder here.
Mm-hmm.
So now down the line, let's say we run this code after 10 days or 20 days, when there is a new version, 4.17, let's say 4.17 came in the HashiCorp. So
Mm-hmm.
our program is not going to download the 4.17. Okay, it will still run on the 4.14 only, even though it satisfies a new version, because our constraint says that 4.14.0, okay, it will run fine on 4.14.1, 4.14.2 till 4.14.9, it will run fine. Okay.
Mm-hmm.
So whatever is currently, it is pinned. Okay, we are currently pinned on 4.14.0.
Mm-hmm.
So
Mm-hmm.
even though a new version comes 4.14.5, okay,
Mm-hmm.
it is not going to download that. Okay, it will continue
Mm-hmm.
to work on this one, whatever we have at this point.
Mm-hmm.
Okay, so that's the
So
thing.
how will you, if you want to upgrade that, how will you do that?
Yeah, if you manually want to upgrade that, so then you do Terraform init, and in that put a upgrade at the end. Okay. So even though
Okay. So
even though your condition is satisfying, like let's say
mm-hmm.
currently we have 4.14.0, but after 5 days 4.14.5 came. Okay. So
Mm-hmm.
our condition is still getting satisfied, right? But
Mm-hmm.
it is not going to download it. It won't download that. But yeah, we want that to be downloaded, the latest one. So then we have to use Terraform init dash upgrade. We are forcing it, okay, to download the
So basically,
latest and
latest
greatest.
version
Yeah,
of
whichever is
AWS.
the,
Okay.
yeah, condition is has still to be
Yes.
satisfied in that upgrade. Okay.
Yes. So I hope while forcing to upgrade, it won't damage anything or affect anything. Um. Yeah.
Mm, no, the minor versions are not. There won't be any impact of that. If you are doing some major version like 4.14 to 5 dot something like that, then yeah, definitely you need to check on that. But minor 4.14 like or 4.19 within the major version, if the major version is same, there shouldn't be any impact for that.
Like if it is 4.15, 4.16, it's
Yes,
okay,
yeah,
right?
it's okay. Yeah, it's
But
all.
it's going to be
Yeah,
5.14, it's going to be problem.
yeah. Yes.
Okay.
There are more forecast, more chances of damaging changes in that major version.
Mm-hmm.
but minor
So
version,
in
yeah, surely.
yeah, so in that case, when there is going to be like minor damages or whatever,
Mhm.
so what can one do to prevent that? Like, what do you need to check? What do you need to put in place? Like, what are the things to consider or to look out for to to
Yeah,
do
yes.
in
So
order for that
in
not
that
to?
case, because there will be first, there are two things are there. One is to go through the documentation, but that is more time consuming. Needs to be
Mm-hmm,
spent on that. Okay. And the second one is on your lower environment and all, you just do a Terraform plan. That's it. Okay. You just do a Terraform plan and Terraform validate. We saw both the things. Okay. So it will tell you where all the arguments got changed. So let's say this code, maybe we are running it after 6 months on some latest
mm-hmm,
version. So what error we may get, I will give you some example. That it may say
mm-hmm,
that, okay, VPC ID is unknown argument. Okay, argument not available in this, something like that. Maybe this VPC ID argument got changed into VPC IDs or something like that. Okay, instead of string, now it is a list. Okay, so
mm-hmm,
something they will give that in the documentation, that this is the new argument. Okay, but in our code it was written as VPC ID. Okay,
mm-hmm,
so these kind of changes is forecasted where the argument name will be unknown, like it doesn't know that. Okay, that argument was residing on the older version, but in the new version, maybe a new equivalent argument is there, or that argument got legacy and deprecated, and they removed it completely. Okay,
mm-hmm,
so you will get the line numbers where which all arguments got. When you do a Terraform plan only, that is known, that is not a damaging test. You just do a Terraform plan, it will go and
mm-hmm.
check the arguments and all those, and based on that output you will start narrowing down your documentation work.
Okay.
Okay,
And
so
then start putting in the right
yes, a right
argument.
argument, yeah, right argument, whatever. So you have to analyze, then you have to go to the next level, that what all you need more analysis. Okay, is it a
So
very
that
minor?
is
Yeah. Hmm.
okay. So that is you manually fixing it first, right?
Manual fix, yeah, yes.
Yeah. So then after you manually fix all those, then you can now upgrade the version, right?
Yes, then you do the Terraform init upgrade. Okay, you put the new version constraint, and you do the
Mm-hmm.
Terraform init upgrade, and then you
Okay.
do the plan again and apply finally.
Okay. Gotcha. I mean, that's simple.
Yeah, definitely. Yeah.
Not so hard, yeah, because we did I told you that we did some backlog,
Mhm.
so we tried to groom our story, like, yeah. So I mean, and we talk about Terraform versioning,
Mhm.
and my colleague made it look as if it's one big deal, and
Mhm.
all of a sudden, it made it look like it's a big deal. You have to be careful, it will take a
Mhm.
lot of time,
Mhm.
like a lot of things need to be put into consideration and all that.
Mhm.
So, I mean, I got really confused that, oh, maybe it's going to be a lot of work, trying to do the Terraform versioning to, like upgrading it and all that. I mean, so right now, you breaking it down and explaining it to me, it doesn't seem that
Yeah,
really
yes, yes.
hard.
Because I'm explaining you on a simple, like a model level, like a small thing, but
Yeah.
you have to see how extensive is your code base. So is he talking about 1,000 files or 10,000 lines of code and all? So maybe is it a size that is a bigger piece of work, but the flow is all same. The logical flow is all same. First, we have
Mm-hmm,
to find out our scope of work.
mm-hmm,
Okay, then narrow it down to
mm-hmm,
by doing a plan and see which all are damaging changes by that update. Okay, and
mm-hmm,
also identify, is it a major number change which is happening, or only the minor number or fixed number. So
mm-hmm,
those kind of, now you got the picture, you can play around with that at your home first. Okay, just to changes this or analyze your work, how what all required version you have been asked to change. Is it a major version change or minor, what all is it? Okay.
okay,
So only
gotcha.
thing what we foresee is point 12, like 0.12 or 0.13 to 1
Mm-hmm,
dot something is a lot of work. Okay, in our past experience also I've seen that. Okay, because there
mm-hmm,
main a lot of design changes have happened in Terraform. So
Mhm.
there foresee a lot of checks to be done and all.
Mhm.
Okay, but if it is same major version, then it is relatively less effort wise.
Mhm.
Okay, so I think that's all for today. Maybe today 1.5 hours is done. Okay,
Yeah,
so
that's quite a lot, and I really enjoyed it. Thank you.
okay, no problem. Thanks. I'm glad to hear that.
All right. See you
Okay,
tomorrow, right?
take care. Yeah, see you tomorrow. Bye bye.
All right. Thank you. Bye.